Hello, everyone. My name is Velin. If you're here, you're going to be hearing for the next, I guess, 45 minutes, according to this timer, about building mobile games in UE. And specifically, a lot of this is also going to focus on kind of the intricacies of building cross-platform and multi-platform type of mobile games. So I'm a mobile gameplay programmer here at Epic. I work on Fortnite specifically, and I've spent the last 8.5 years basically of my career primarily focused on mobile. Those last 3.5 years, however, have been focused on multi-platform, and I can tell you the last almost decade has been a crazy ride. So this talk is going to be a lot of just high-level concepts of everything that I've run into that has caused me pain, that has made me get excited, and everything in between. So the high-level basically concept of this talk is going to focus on 3 pillars. There's going to be gameplay, so basically touch input, things around mobile UI, networking, how do you iterate when it comes to building for mobile, to get to the point of having a fun gameplay experience. The second pillar, also very important, is performance. Of course, mobile spans a huge range of device specs, everything from 2-3 gigabyte RAM devices to devices that don't have 5 gigahertz Wi-Fi signals. So if you really want to support mobile, how do you actually end up supporting that wide range of devices? And then finally, content. This one is especially important if you're building a multi-platform game where you plan on launching everything from high-end PC, console, all the way down to those 2-3 gigabyte mobile devices that I was mentioning. What are some of the optimizations that you can do, and how do you think about content when you're building in that sort of direction? And I'll be using different examples, of course, from what Fortnite currently does, as well as just some of my prior experience on other games that I've worked as well. So why mobile? That is kind of the first question. Everyone gets scared when we talk about mobile because of, again, the different device SKUs, of how do you play with touch input, all that sort of thing. And to be honest, I think for every person, it's going to be a different question of why do you actually want to build a mobile game. For me, it is primarily because of the amount of players that exist in the world that can only play on mobile. They don't have PCs, they don't have consoles. For me, growing up, games were the way that I connected with my friends and with others around me. So now as a game developer, if I'm able to create experiences that allow others to connect globally within their community and such, that's a win in my book. And here's some statistics because that always helps, but it goes without saying there are a lot of mobile players around the world, and as a game developer, I kind of want to support them. The other aspect, though, is, especially if you're building a multi-platform game, is that in essence, building for mobile allows you to also support your other platforms better. Because at the end of the day, the optimizations that you end up doing for mobile don't end up being contained just within the mobile platform. So, for example, you end up optimizing your content, implementing LODs, that sort of stuff, to get mobile running. Great, now you can support lower spec PC players as well. Similarly, if you end up supporting like the poorer network conditions that usually exist with mobile devices, great. Now players that have weaker internet connections playing on PC and console can also be part of your community and part of your game. Other aspect is mobile's just accessible. And a lot of the challenges that come up in regards to getting it feeling good on a small screen with just using your 2 thumbs to play result in better UX flows, better gameplay flows, et cetera, that then translate to, again, on a bigger screen, on PC console with gamepad, mouse, keyboard, et cetera. And finally, my favorite one is it gives players the option. I can play at home on my big screen with my console if I want to, but then I can go out and sit at a coffee shop while I'm hanging out with my friends and play on my phone as well. I don't have to feel like I'm limited because I've chosen to play on just one platform. And then this is, if there's anything else to take out from the multi-platform side of this talk, this is the most important thing. Most of the features that you actually have to build from a gameplay perspective for mobile are platform agnostic. In my opinion, the worst thing you can do is if you already have a defined game and now you're going to build a mobile port on top of it, you're going to run into so many issues, not in regards just to performance and content optimization, but just from the gameplay feel as well. If your game requires very precise aiming, suddenly, are you going to support that level of precise aiming on mobile? How's that going to feel with 2 fingers, basically. Like, the earlier on that you can include mobile in your pre-production and in your prototyping to really figure out what your game is going to be, the better it is going to be from a multi-platform perspective. So let's kind of dive in with kind of like the different player expectations. This is basically your ground zero. If you're going to launch a mobile game, this is what players are going to expect that actually exists within your game so that they can play comfortably and have a fun time. The first one, as I mentioned, is everyone is going to play with 2 thumbs. This is a bit of an issue because gamepad, let's see, you get, I don't know, 4 simultaneous inputs at a time. Keyboard, mouse, honestly, you get a lot more. But with mobile, you only get 2, which can make it very difficult when it comes to things such as I need to move, aim, and shoot at the same time. And what you're going to find is that a lot of your design is going to turn into having to figure out how to overlap actions that can happen at the same time. Now, for expert players, there is claw, but do not build with claw being the default. I get cramps whenever I try to play with claw, would not recommend it. As mentioned, again, with just 2 inputs, 2 thumbs basically on the screen, and with a wide variety of screen sizes from tablets to phones, etc., as well as people having different hand sizes and finger sizes, it is important to offer HUD and input customization to your players as well. That means players should be able to move around where their movement joystick is, where their fire button is, where the mini-map is, and so on, and be able to augment things such as, I want it to be this size, I want the interaction portion of it to be this size. This allows players to really fine-tune their input to fit their hands. Second, since also touch input does not have any sort of physical feedback, it's important that gameplay reacts immediately. If there is any sort of delay visually in your gameplay of showing from a player doing any sort of action, they're going to think, did I actually press the right button? Or they're going to start looking at the side of the screen to make sure they're in the right place. Just doesn't work. Other thing also to consider is that at any point, the player can decide to switch their input type. And this is something that Unreal does support with the Common Input API. So at some point, a player can decide to plug in a Bluetooth controller to their device, and then the question becomes, okay, what happens to the UI? What happens to all my touch buttons that are on the screen? Similarly, if you're creating a competitive game where people are match-made based off of the input type that they're currently using, maybe you want to lock that input type. So if you started with touch input, I'm not going to let you actually change to gamepad afterwards. You have to start a completely new match in order to play with gamepad. It's all up in the air, but it's something that you have to consider early on, especially when you're building your UI systems, because you don't want to end up in a situation where it's like, hey, we have our HUD, we have all the ways that we're responding to it from gameplay state, but we didn't consider what happens when players are changing their input type. The other aspect, and this gets actually me really excited about touch input specifically, is I consider it the main input type that allows you to really communicate player intent into what you see in game. So I don't know if you have, for any of you that remember Infinity Blade, being able to cast spells require you to actually draw the rune on the screen. And that is something that is very unique to touch input. You don't really get that same sort of feel with keyboard, mouse, or gamepad. So when you have options to really leverage the fact that every single input you have on the device is a pointer that has some associated velocity, acceleration, appears on some portion of the screen, use it. It creates really unique gameplay moments that really only exist with touch input. And also, most players on mobile don't play with audio on. So obviously, if your game audio is important, definitely warn your player. I've seen a lot of mobile games do that. But also be ready to play without audio. So Fortnite, for example, solves this because we have that audio visualizer that occurs at the center of the screen, which also helps as an accessibility option as well for players who are hard of hearing. But just keep in mind that audio may not always be available to your players. Other big important part is no frame rate hitching. Nothing feels worse than lining up that sniper shot and getting a hitch. We'll talk more about kind of the different things that cause hitching later on, but on mobile, especially being a lower spec type of platform, this can become more prevalent and more visible. Otherwise, the rest of these are pretty standard in terms of mobile. Like, you don't want the device to heat up substantially. If it heats up too much, the operating system is going to start throttling your device, and suddenly the 60 frames per second that you have is going to drive down to 10 frames per second, and there's nothing you can do about it. Similarly, battery, there's no really amazing solutions for this outside of optimize, optimize, optimize. But if players can at least from 100% battery life play for about 3 hours without having to charge their phone, that's a win in my book. And finally, the most important part is if you are building a type of game, such as Fortnite, which has cosmetic purchases that the player can either pay real money for or spend their time in game to earn, remember to value that purchase. Nothing feels worse to a player, especially if you're building a multi-platform game, to see I've spent the same amount of money as a PC or a console player, my cosmetics look worse. Like, that just isn't fair. So let's dive into the elephant in the room, which is primarily touch input. You have to get this working basically during your prototype phase and moving into pre-production. Otherwise, it's going to be hell to try to test your game. So touch input, at least for the implementations I've done, always lives within the UI layer. So while keyboard, mouse, and gamepad, you'll be using enhanced input, potentially with input mapping contexts, and that's how you define your actions. With touch input, you're going to be doing kind of a similar thing, but it's going to be living within UMG, Slate, UI, basically, whatever you want to call it. Additionally, I put this as an asterisk, and this is the first bullet point. Touch is an input type. Mobile is a platform. It doesn't mean that mobile needs to be just touch input. Similarly, there are PCs out there and laptops that support touch input, for example. So it's something to consider when you're building out your UI layer. Where is the distinction going to come of, like, I'm showing this widget or I'm not, or this is going to scale this way based off platform or input type? Just keep that in mind. So the base possible events that you'll be using to construct your touch input are the ones that you see basically at the top there. On-touch started, on-touch move, on-touch ended, and the ones that are a little bit more rarely used, on-mouse enter and on-mouse leave. In general, with touch input on mobile, there are two type of input patterns that are fundamental to everything. The first is I want to be able to start my input and drag it anywhere on the screen, even if I'm not in my widget bounds anymore, and have the input continue. And the other one is I want to be able to start my input somewhere, and I want multiple UI elements to be able to register for it. So basically pass through. So for the first one of being able to track basically outside of the widget bounds, the usual thing you're going to be using is an input processor. So you will have to do this in code. This is, from my knowledge, not readily available within Blueprint. But basically, this gives the input processor a stab at pointer input before it goes into the UI layer. And just as a refresher, usually what ends up happening with the UI layer is based off of Z order. It determines this is the widget that is going to be reacting and be able to handle the input first. And then afterwards, if it decides to return unhandled for the input it receives, that goes up the parent hierarchy of your widget. So the input processor becomes before that. So keep in mind that if you do return true on the input processor, interface-like functions, it stops there. It never makes it to the UI layer. For input pass-through, I would suggest looking at Common UI. Their actual common user widget does have a Boolean flag for consume input. But input pass-through is basically what you're going to be using in order to achieve something as I want to fire a weapon and allow the player to move their camera around and such. Similar, as I mentioned earlier, common input is a great way for actually tracking what is my current input type and responding to changes when that input type changes. You can also lock the input type through that API as well. Kind of moving on, once you have that like kind of foundational start, moved, and enter, leave sort of logic, you'll probably move into gestures. Like that's always been associated with touch input. So you have things such as tap, swipe, hold, double tap, some sort of sequence such as like a tap, swipe, tap, a drag, et cetera. I think gestures have their place, but take into consideration that gestures inherently introduce input latency. So if I have on one widget, basically I have a tap action and I have a completely different swipe action that happens on it, I have to wait until I can determine that my input is either a tap or a swipe before I can trigger anything downstream. So if a swipe takes a maximum, I don't know, 200 milliseconds, basically, that's the threshold for a swipe, guess what? You're waiting for 200 milliseconds before triggering any sort of downstream action, regardless of anything else going on. Similarly, as I mentioned, enhanced input, that's kind of going to be your go-to, but you're not going to be using input mapping context. There is an API now about injecting input into the subsystem. There are some quirks with it. I'll cover some of that on the next slide, but in general, you can actually inject input for input actions through UI into the enhanced input subsystem. So let's just move on to the next slide, which is the big asterisk is UI has its quirks. A lot of the stuff, as I've been diving into Unreal over my career, is like, this doesn't really make sense. So this is some of the stuff that I've noticed. First off, just because you get a touch start event on a widget does not mean you will get a touch end event. It is not a physical key like on a keyboard where you're guaranteed to get a pressed and released sort of trigger. If you press and then drag your finger outside of the bounds of the widget and release, touch end will not trigger on the widget. So this is where the input processor comes in, because you can say, okay, on start, I'm going to start tracking input with this ID, and then the input processor will start feeding in additional events once it's outside of the bounds of the widget, and that's how you'll see that like it's ended or something through there. Similarly, mouse enter and touch start usually end up triggering both when you start an input right on a widget. So if you are doing any sort of logic such as tracking, this is the ID that I'm currently tracking, you only do it once. As I mentioned earlier, the input processor triggers before the widget receives input, and if it returns true, that's it, input is consumed. So just keep that in mind. If you do want to do any sort of additional input pass-through, that sort of thing, don't consume it. So to the right, you can see actually those APIs I was mentioning for enhanced input. But the big thing, I would actually recommend to use the start continuous input and stop continuous input APIs, because those will at least maintain your input action values that you inject, even if you don't inject them every frame. Unfortunately, for the other APIs, inject input for action and vector for action, if you have a frame where you don't inject an action value, it'll default to 0. And remember, touch moved isn't triggered every frame. It's only once it's above some, I don't know, magic number threshold that it gets triggered. The other big issue is, technically, if I can fit 5 fingers on top of one button, that button will receive all 5 of those inputs. So it's important for your base kind of like touch input class or whatever UI user widget you end up making for your project to have a concept of I will only respond to 1 input at a time or 2 inputs, whatever, some number. Otherwise, this can just, you'll get a lot of edge cases, you get a lot of bugs. I've spent months solving these bugs on previous projects. And I'll admit, this is a lot to ask of any developer to basically go in and have to implement all of this stuff additionally on top of the engine on their own. There really isn't an amazing framework at the engine level right now for touch input. It's something that I'm fighting for and I'm hoping we'll get in the future. But I'm hoping that this aspect of it helps you get started for your own projects on the main considerations, at least in regards to touch input. And the other aspect of it is also iteration. So touch input is gameplay, but making mobile builds sucks. It just absolutely sucks. It takes hours, and if you are going to be iterating on, I want to see how my dead zone feels, or I want to see how a double tap versus a swipe feels, building to device is painful. So at least for me, and internally as well in Fortnite, we basically use these 3 steps, with the top one being what I use the most. First off, if you go into editor preferences, there is an option, I think it's like use mouse as touch, that will simulate every left mouse click with the pointer as touch input. That is the first way that I go about with everything that I test in regards to touch input. If I need to test the feel of like multiple simultaneous inputs, at that point I start using the Unreal Remote app. This basically turns any phone you have, whether it's Android or iOS, into just kind of a streaming screen for whatever is happening in the editor. And with that, you can kind of test around. It's not perfect, especially if you're on VPN, there can be a lot of latency. with this, but it is a great way to be able to test the feel of, I don't know, movement plus camera without having to deploy to device. And finally, the big one is just always play test. At least internally, our motto is, let's just get a build in the next day or 2 days from now, go play test it, get feedback. The more that you play test, the more you're gonna find out what works and what doesn't work. Touch input is one of those things where, since it's such a new input type compared to keyboard, mouse, and gamepad, there aren't a lot of defined patterns of what feels good and what doesn't feel good. For the most part, I think a lot of our approaches currently are, let's just put a button on the screen for everything. And I'm convinced that that maybe is not the correct solution in all cases. So I challenge you all to go out and experiment and try different patterns, because you could be the person that basically figures out how to do third person amazingly on mobile when other people struggle. And then if you're building for multi-platform, I also encourage you, at least on the client side, so if you're a server, please do not put platform-specific checks based off of what the client is on the server. There's a lot of security risks around that. Players can potentially cheat. So on the client side, don't be afraid to diverge on how the client behaves based off the platform and the input type that you have. So that includes things such as aim assist, which is available on gamepad and for touch input, but can also dial down to other things such as, hey, when you're on a smaller screen, I am going to outline the enemy players. I won't do this when you're on a larger screen because easier to see, but for smaller screens, I'll do that. Similarly, like with damage text, if you're on a smaller screen, I don't want to see 5,000 unique damage text numbers popping up all over the screen because that is all I am going to see. It might be more worth it to actually aggregate those numbers in a way so that it's more readable to the player. And then a big one also, just for player usability, is give players the option to change their settings while they are in the game. Most of the time, if they have to go out into the front end, change their settings, and get into a match to kind of get a feel of what those setting changes are, that's just too long of a loop. Like they should be able to, there should be some like more condensed settings menu that allows them to modify their values while they're in game and see the results of those. Now, when it comes to networking, decide early on what sort of networking conditions you as a multiplayer game are willing to support. If that means that you're only willing to support like typical PC console latency of, I don't know, 40 milliseconds or something, fine, but at least define it. Because the longer it takes for you to define what that minimum is, or the worst case is, the more impact it will have on your design choices down the line. So for mobile, my experience is usually 150 millisecond round trip is normal. And then you can expect usually a 300 millisecond burst every minute or two. But yeah, you will have higher latency, jitter, packet loss. And while you can have different technical solutions to try to fix these, for the most part, this has to come from your design. And accepting that for the fact that there are some genres that probably will not work with that level of latency. You can iterate under these conditions in the editor. My suggestion is to basically tell all of your designers to go into editor preferences and enable network emulation with whatever your threshold is and have them test all of their designs under those conditions. Because if they work under those conditions, that on slower latency, on better latency basically, they'll be better. And finally, communicate to the player. If you don't tell the player that, hey, your network condition is bad, you probably shouldn't play this match because you're going to have just a horrible time, they're gonna think that something's just wrong with your game. So go in, warn the player, have some sort of pop-up, track basically how stable their connection is, and communicate it back to them. Now you found, okay, your fun gameplay, but none of this matters if it actually doesn't run on your mobile devices. So for me, as I'm building out gameplay, I always consider performance to be something that I do in parallel with it, not something that I do 3 months before ship, basically. So mobile players definitely require stability. And as being the lowest spec platform out of console and PC usually, they suffer from things that aren't optimized a lot more than your other platforms. So for me, I consider get at least 30 frames per second stable for low spec. For higher specs, you can go to 60 frames per second, maybe even 190 or 120. You want minimal hitching. Basically, again, that sniper shot example, I want to get my sniper shot off. I do not want to suddenly miss because my game froze. No memory crashes. You want reasonable device temperature, again, the battery life. And then the big caveat is while each mobile device might have up to use like 3 GB RAM, 4 GB RAM, you can't use all of it. If you use too much of it, the operating system will force close your application. I've generally found that for lower spec devices, it's usually good to aim around 50, 60% of the total memory available on device. So for 3 GB, that's 1.7. For higher spec devices, you can bump that up towards like 75%. But again, there's a lot of variability because if the player has a lot of other applications open in the background, that can also affect what memory is available to your game. So now we go into the section where it's kind of like the usual culprits that I've seen for a lot of different problems. So the first one is culprits of hitches, my favorite. Big one is garbage collection. First off, turn on incremental GC, that'll help. Use object pools for things that are going to be destroyed and created often, such as projectiles. And also consider maybe turning off garbage collection during critical gameplay. Yes, that means that if your memory management is not great, the game may crash, but at least if there's no garbage collection, that risk of hitching is gone. The next aspect is asset loading. So don't wait for, how to put it, the time that you need the asset in order to load it then. Always be preloading if you can. So if you're entering into a match where you know this is my level, or you're entering, I don't know, you have a more node-based design where I'm going from one area to another area in my game, consider preloading based off of what the player is just about to go into before they actually need those assets. Otherwise, your other solution is going to be to async load stuff, which first produces artifacting because now the player is, I don't know, seeing cosmetics pop in or weapons pop in once the async load completes, but also too much async loading on mobile can end up causing performance issues. And then finally, the other aspect is PSOs. The previous talk actually talked about how in 5.4 there's going to be a runtime PSO now, so you don't have to go through the process of recording and caching and finding all your PSOs. But in general, what it means is that if PSO is not cached beforehand, the first time that the game hits it, you'll suffer at least a 100 millisecond, if not more, hitch while it caches it. Thankfully, it only happens once per instance, but if you update your game, you have new content, it'll happen again. But like I said, at least with 5.4, there's now a runtime solution for this. So if you can wait for that, great. You probably don't have to worry about this. But if you're going to be launching your mobile game soon before 5.4, then you're going to want to look into PSOs and caching them with your build. So the usual culprits of low frame rate. The first one is overheated devices. If you don't manage basically the heat well for your device, eventually the operating system will manage it for you. My usual solution that's proven pretty effective is to pick specific moments of your game where you can force the frame rate to be lower. So if you have like a intermediary buy phase between rounds in your game, maybe the buy phase is going to be 30 frames per second instead of whatever the player set it at. Similarly, when the player's in the front end, just cap their frame rate. So while they're in the front end, the device has a chance to kind of recover. Draw calls. We'll say it all the time. If you have too many unique meshes, too many materials, it's just going to hurt on mobile. It's going to hurt on your other platforms as well. And then again, low frame rate, asset loading and unloading can lead to performance issues. For high memory usage, this is usually going to come from your references. So I prefer, and I kind of encourage the engineers on my team, that basically anytime we define some sort of variable, field, whatever, that we use soft references and weak object pointers whenever we can. That saves us a lot of pain down the line. I'm sure all of you have seen those reference viewer graphs where it looks like a massive spider web and you don't know where it starts and where it ends. That's where this comes from. And detangling those down the line after you've developed a lot of content, I mean, is an issue. It just takes a lot of time. It's a lot of manual work. So prefer to start with very concrete, like my class will own this object that it creates, but every other place that uses this object will use a weak object pointer, for example. The other aspect is blueprint inheritance. This is one of those things that I randomly found out on a game I worked on a few years ago. where we were bringing content that none of the players in the actual game were using. Well, the reason for it is because of blueprint inheritance. Every parent in your blueprint chain is going to have all of its content loaded in it, even if that content ends up getting overwritten by a child. So as an example, if I have a goblin NPC that has my base goblin skeletal mesh. And then I create a goblin warrior NPC that inherits from that, and I override the skeletal mesh with my goblin warrior mesh. Guess what? When the warrior gets loaded, so does the base mesh as well, because it's in the parent. So usually my approach is to have an abstract class that's defined in code, then have a blueprint that inherits from that abstract class that is also abstract and doesn't have any content defined on it, but may have like additional logic that I'm iterating on. And then from there, I have my blueprint that inherits from that abstract blueprint, and that's where my content actually gets defined. And speaking of content, the other issue with high memory usage is unoptimized content. I run into texture compression, texture basically issues all the time. If you want to use MIPS, they have to be power of 2. Meshes, you can't use a 300,000 vertex character model on mobile. It's just not going to work. You'll have to set up LODs. Whether you decide to use the auto LOD system or create custom meshes for each LOD level, that'll be up to you. And so on. Like for the most part, a lot of memory usage is also just going to come from like your content isn't structured properly. And the Unreal documentation actually has a lot of really great examples of how to optimize content for mobile, so really suggest that you check it out. So these are kind of like basically the main tools that I use in regards to performance. So at least within Editor and available with Unreal, there's Unreal Insights. So that's how I do my CPU traces and basically figure out why is my game thread suddenly slowing down. I use memreport all the time to figure out if I'm loading stuff that I don't expect to actually be in my level. And then of course, reference viewer to kind of figure out how to break those asset loading chains. Now, if you're building a live service game, I also recommend that you actually invest in some sort of solution for telemetry. Something that where you can capture in production, in live from players, basically see, hey, this is, during a match, this is my average frame rate for this user, this is my average, or this is my max memory usage, just very base details like that, also coupled with the actual device profile, device name that they're using, so that way you can see if there's immediately a problem for like a certain section of your, like only low spec devices on live are currently having problems. Or potentially, I've had this happen in a game before, all of our high spec devices are suddenly suffering massive frame drops. We would not have found that out if we didn't actually have some sort of real-time telemetry solution. So I think like Tableau or Grafana are the ones that I've used before. So now we dive kind of into content. I like to make the statement that mobile games can look good, but it's going to take work, and you can't consider that you're going to get everything for free. And this is especially true if you're building multi-platform, where potentially you're going to start with a very high-res asset on some platforms and then try to get it to super low-res for mobile. So for me, the big important part of that is scalability. As mentioned earlier, mobile just has huge ranges in device spec. There's different solutions within Unreal of how to do that. So from a technical perspective, set up your device profiles, set up memory buckets. These are all things that are part of your INI files. And the big one is use a significance manager. I don't think it gets enough attention it's more of a, how do I put it, a concept than it is a fully fleshed out system. But the idea behind it is my gameplay state is going to be changing as the player is playing, so let me adjust at runtime the visual fidelity, how often AI runs, how pausing or turning on animation, that sort of stuff. So a lot of people use it in regards to distance. So for example, if another player is too far from me, or another actor is too far from me distance-wise, its significance is low. When significance is low, I will turn off animation and not even play it. So otherwise, other solutions are kind of this like bullet point list. A big one is texture streaming. You can set up a texture streaming pool, and with device profiles, you can augment what that pool size is going to be for each of your different tiers and definitions. So If you have a lot of textures and a small pool, that just means that your textures are going to look bad and blurry. But that is also a good way to basically enforce, I will never go above this limit for textures, and if it starts looking bad, that means we need to start optimizing. As a little note, do not put UI textures as part of texture streaming, otherwise your UI is going to start getting blurry and sharp and blurry and sharp, and it just looks really weird. I would just set a hard, like, here, I have 30 megabytes, that is our UI texture memory, and respect that. And similarly, you have texture groups. This allows you to basically say, for your different device tier thresholds, I want my character texture group to be medium quality, I want my environment to be low. It allows you to scale stuff up and down depending on how you organize it. But ultimately, it is up to you to organize it in a structure that makes sense for your game. There isn't like, I think there are some predefined actually texture groups in there, but in general, you decide what they are. At the end of the day, it's just data, and you decide how to hook it up. For LODs, you're most likely not, if you're multi-platform, you're not going to be using the max, most beautiful mesh that is available to you, because even on a small screen, no one's going to be able to see it, and it's not going to be performant. One caveat that I will say with this is that when you do use LODs, be very careful with bone reductions. If other part of your gameplay actually depends on positioning, like an ability where it starts or something like that based off of where a bone is, that bone may not exist on your lower LODs, and you're just going to end up with an arrow firing out of your character's chest. As mentioned before with animation, with the significance manager, you can use that to like pause and basically animation that's in the distance, but also make sure to use animation compression. We have a lot of different offerings basically in there, and they work pretty well. And from my experience, like they help quite a bit. And then finally, there's just a massive amount of CVARs that are available throughout your entire project, throughout Unreal in the engine, but you can also define them yourself. Use those with your device profiles to basically decide what quality I want my texture, what quality I want foliage, content scale factor, resolution on the screen, etc. Like the list is pretty massive. And finally, the last portion of it is storage is limited. In general, like I think console kind of suffers from this as well, especially nowadays when there are games that can take up like 120 gigabytes of hard drive space. But mobile definitely suffers this a lot, especially players that are in countries that are using much lower spec devices. My usual is target for the initial install to be at most 200 megabytes and have it include a playable portion of the game. I'll admit we don't do a great job on this in Fortnite. You can see that loading screen on the right-hand side. Depending on your internet speed, you're going to be watching it for the next 40 minutes. So by having a portion of the game that's actually playable allows players to actually get in and not just be waiting around. And then instead of having patching screens, patch in the background. While the player is going through different menus and stuff like that, start downloading the content while they're actually playing your game as opposed to looking at a screen. And the other aspect is kind of like the content on demand, the whole idea being that instead of patching everything at once, I will only patch stuff as I need it. So I enter a match, I see that someone is using a new skin that I haven't encountered before, I'm going to download that skin at that point and such. Additionally, always ask your players if they want to download over cellular data. Don't be that game that suddenly blows through someone's data cap for the entire month. I've had that happen on a few occasions, some mobile games I've played. I will not name them, but default otherwise just to Wi-Fi. Also keep in mind that blueprinting content can be patched, but code will require a binary update. In general, players are not the biggest fan of having to go every week or every few days to an app store and having to update their application. When they decide they want to play, they want to go in right away. So if you can limit your minor releases to be just blueprint and content updates, and then have your major releases, which are once every month and a half, 2 months, something of that sort, to code updates, that'll be a happier player population. I will also just say in terms of VO, because this is a very specific call because I've run into it, please do not bundle all of your localized voiceover in the initial install. If you want, you can make separate builds that, depending on region, have one VO package already part of that build. You are going to balloon the size of your game immediately with that. And then this one is something that I really haven't seen mobile games do well, like for live service games, is how do you make it so the install size doesn't completely grow over time to the point where you started at 2 gigabyte game 5 years ago, and now you're suddenly at an 80 gigabyte game. There's some technical solutions potentially to this. They're not part of Unreal, they're just something you'll have to come up, but a lot of this for me comes from a design perspective. If you have the concept of at least vaulting content, sunsetting different, I don't know, dungeons or experiences or things like that while you introduce new ones, you can hopefully kind of keep the install size in check, even if your game ends up running 5, 10, 15 years. In regards to in development, I do also want to point out that in general, the approach that I found that works the best for me when I want to test my content is building out my build process so that I can select, I only want to build this portion with this map and not everything else. I don't need all the cosmetics. Like a lot of time with gameplay, or if I want to get like some designers in a playtest with me, I'm just like, I just want to test this one map with these rule sets. I don't want everything else in there. But again, that is something like you'll have to tinker with in order to figure out. It's just something I recommend if you don't want to wait for long builds. And then the last portion of this is just set up your dev budgets for content. There are systems within Unreal that allow you to write like data validation just to ensure that you're not checking in improperly sized textures into your repository. This will save you in the long term. Like I would actually recommend as you're developing your content workflow that you define what are our actual budgets, what are the specific ways that our content needs to be structured, and write tests around those. And that way, any artist and designer that goes in has to implement it in that sort of way. That way, you prevent a lot of headaches down the line. So that's kind of like my very quick, hopefully quick brain dump of everything that's bothered me and excited me about mobile during my career. But if you have to take anything away from this talk, it'll be these bullet points specifically. So it's mobile features are mostly platform agnostic. So when you scale your content, it helps your other platforms. When you build out your significant manager, it helps other platforms. When you build out your UI to support input pass-through and whatever, again, helps other platforms. Touch is an input type. Mobile is a platform. You will have headaches with your UI systems if you do not differentiate between input type and platform that you're on. Build content with scalability in mind. A lot of it is going to be tinkering around to see basically for my game, what is the visual bar that I'm aiming for, what is feasible within the technical restrictions that we have. Play around with it. There is no solution fits everyone basically approach. Always be profiling, always be playtesting. Don't wait until the last 3 months to suddenly start running performance tests and figuring out if you can suddenly run your game on your low-spec platforms, especially since a lot of us use pretty high-powered PCs sometimes to develop our games. I feel like we get blinded about if our game is actually performant or not if we're not actually testing on those lower-spec platforms. Touch input can be the most accessible input type if customization is offered. That one is a pretty big one for me. I think while it is still possible to have a fixed HUD and fixed options, giving players the ability to move their buttons around or define which buttons are on the screen or not, that sort of thing, just feels better. Also, slow internet doesn't have to mean a poor multiplayer experience. Again, at the end of the day, you're not going to beat the speed of light, so design with those networking thresholds in mind. And most importantly, build and design with mobile from the beginning. Do not push it off as a port, something that happens 3 years, 4 years, 5 years down the line after you've built out a successful game. Consider it as something that you build in parallel the same way that you would build out a game that's coming out on PC and console at the same time, or a game that is going to be supporting keyboard and mouse and gamepad at the same time. Mobile is just, well, we add another input type and we add another platform to that list. Don't leave it to the sidelines. So yeah, that is everything. I think we can move over to some questions. For those that have any, please come up to the mic in the front, and I'll be happy to spend the rest of the time that we have answering any questions. Thank you.